Begin our Unit 3 study guide by looking at atomic structure. Remember that when we learned about atoms, we learned of two ways to describe atoms. First, we know that atoms are the basic building blocks of matter. We also know a very precise definition of an atom, that it is a dense nucleus of protons and neutrons surrounded by an electron cloud. We also know that atoms are mostly made of empty space. Now let's fill in the diagram shown. In the center of the atom, we have the nucleus. It is made of neutrons and protons. In this picture, make sure you label the protons as the ones with the positive sign. Surrounding the nucleus are the electrons. In this picture, the electrons are shown in a cloud, which matches our most current model of the atom. Now let's fill in this diagram and fill in the chart below. When we're looking at our different particles, remember that our protons and neutrons are both located in the nucleus. I'll write N for nucleus. We know that electrons are located in the cloud outside the nucleus. I'll write C for cloud. We know that protons and neutrons are both part of the mass of the atom, which means they're counted in the mass number. Electrons are too small. They have mass, but it's so insignificant that it doesn't count in the overall mass of the atom. We know that protons have a positive charge, while electrons are negative. Neutrons do not have a charge. We'll leave that box blank. We know that all of these particles are very tiny, but compared to each other, we know that protons and neutrons are identical and they're both considered large, while electrons are much smaller, so we'll write small. We know that protons and neutrons are both made of quarks, while electrons are not made of anything that is smaller, at least that we know of so far. Take a minute and make sure that your chart is filled in like mine. Now let's go on and talk about atomic symbols and particles. We know that in a particular atomic symbol on the periodic table, we'll see a number that's typically above the symbol, and that shows us the atomic number. Atomic numbers are always whole numbers. It's always the smaller of the two numbers that you see on the periodic table. The symbol for the element will be either one or two letters. If it is two letters, the second letter must be lowercase. Finally, at the bottom of the periodic table box, we'll see a number that frequently includes a decimal. This is the atomic mass. For carbon, this number is 12.01. We learned that for our protons, neutrons, and electrons, we can use these numbers to help us figure out how many of each particle we have in an atom. Of course, you don't need this if you're looking at a picture of an atom when you can just count the particles. But if we can't count the particles, we'll need to use these rules to help us figure out how many particles there are. The number of protons always matches the atomic number. There are no exceptions to that rule. The number of neutrons is a little bit tricky. It's not shown on the periodic table, and remember that elements can have more than one possible number of neutrons. Changing the number of neutrons won't change the element itself, but it will change its mass, and it will cause it to be a different isotope of that element. To find the number of neutrons using the periodic table, we'll round the atomic mass, that's the one with the decimal, round it to the nearest whole number. For carbon, this would be 12, because 12.01 is closer to 12 than to 13. Then we'll subtract the atomic number. So we'll do 12 minus 6, which gives us 6 neutrons. For smaller elements, it's fairly common for the number of neutrons to be similar to the number of protons. When the elements get to be very large, the number of neutrons tends to be bigger than the number of protons. Finally, the rule for electrons. This rule applies whenever the atom is neutral, and we will tell you if the atom is not neutral. If the atom is neutral, the number of protons equals the number of electrons. So we use the atomic number again to tell us how many electrons there are. For carbon, there are 6 protons, 6 electrons, and 12 minus 6 gives us 6 neutrons as well. Let's use these rules to practice. With aluminum, we see the 13 at the top. 13 tells us that this is our atomic number. 13 tells us that there are 13 protons. It also tells us that there are 13 electrons. I like to do these two together because they're the easiest ones. Then our neutrons, we'll round 26.98 to 27. We'll do 27 minus 13. 27 minus 13 is 14. So the most common number of neutrons for aluminum is 14. Next, we'll look at zinc. Zinc has an atomic number of 30, which means it has 30 protons, 30 electrons. Its atomic mass of 65.38 will round down to 65. 65 minus 30 is 35, so there are 35 neutrons. Finally, we'll look at potassium, whose symbol is K. Potassium has an atomic number of 19, so it has 19 protons and 19 electrons. Its atomic mass is 39.10, which rounds down to 39. 39 minus 19 is 20. Finally, let's look at how we can calculate the mass number. But there are two ways to find the mass number. If we're looking at the periodic table, take the atomic mass and round it to the nearest whole number. Remember to follow the rounding rules from math class. If the number after the decimal is a 5 or above, round up. If the number after the decimal is 4 or below, round down. If you're looking at a picture of an atom and you can see the protons and neutrons, simply add the protons and neutrons together to get the mass number for that particular isotope. Remember that atomic mass and mass number are both telling us the mass of an atom. Atomic mass is the average mass of all the isotopes of that element. This is found on the periodic table. Mass number tells us the actual mass of a particular isotope of an element. Remember that there are multiple possible isotopes of any element. We'll use the mass number when we're looking at a single atom where we can see how many neutrons are in the nucleus with the protons.